Okay, video active. All right. So let me rewind. So, I did. We covered 3 ways of solving systems of equations so far. Graphing, substitution, and we just touched on elimination. I want to cover a bit more on elimination today. But, can somebody tell me, first of all, what is a system? What is a system? Like a system of equations is what?
It's more than one part.
More than one part. So a system of equations is more than one equation. So if you have 2 equations at the same time, you need a technique to solve both at the same time. So for example, solve by elimination. Try this. 3x plus 7y equals, let me just think. 31. And then 5x minus 7y equals, hang on a second, 33. Can somebody tell me how to solve that? Now again, you could try and graph it. I would not recommend that. If anybody, just taking a glance at it, you probably figure out that the chubby hand method for graphing would be pretty brutal. Just look at the top one. Oh, chubby hand method, I'll cover this up. 3x equals 31. Ouch. Divide both sides by 3 and you get x equals 31 over 3. Not the most friendly thing to graph. The other one is worse. 31 over 7. Yeah, where's that? I don't know. So, and then you'd have like 33 over 5 and negative 33 over 7. And by the time you're done graphing, where do they cross? There's no way to know. Yeah. What's that? Add them together. What makes you think, you're right by the way, what tipped you off that that might be a good idea? What looks like it might happen? The 7y's cancel. The whole point of elimination is to get one type of variable, VAR, to cancel. That's the whole secret of elimination. If they're ready to cancel right away, bonus. Merry Christmas early. Go ahead and start me off then.
So 8x.
8x, and these are gone, equals,
I'll keep going.
yeah, 64. What can you do with that now? Go ahead and finish this one.
You would divide both sides by
Correct. What do you get?
3.
Bingo. You're half done and it took like 15 seconds, which is very, very nice. This is one of the reasons why elimination is so incredibly popular among people who solve for systems. Can somebody finish this problem for me? Let me see. Go. Yeah, now I've got x. By the way, you could try and eliminate the x's, but there's a quick way. You know what x is, what do you do with it? Yeah, so like, well, my mom is fond of saying, the best way to show gratitude for a gift is to use it and enjoy it. She also says, write a thank you note, of course. But that's not part of the metaphor. In other words, how do we appreciate x equals 8? Plug it in, use it. I don't know, I could plug it in the top or the bottom, anywhere there's an x. I don't know, what's your favorite? Sure, got it. 3 times 8 plus 7y equals 31. Go ahead and do that. 24 plus 7y equals 31. Keep going. Subtract 24 because that's farthest away. Good. What do you have? 7. Merry Christmas. Go ahead. Exactly. Divide both sides by 7. Y equals 1. Done. That's elimination. If you can get one type of variable to cancel, you're in business. Now, there are problems that don't quite lend themselves so easily. For example, I don't know. 5x plus 2y equals Now, I would like to solve by elimination because it's so fast, but if I added those two equations right now, would anything cancel? Megan. Would anything cancel if I added these right now? No. Which one looks like it's trying to cancel? The x's or the y's? Yeah, why do you say that? No pun intended. Yeah, one is adding, one subtracting. They're already fighting each other. Sorry about the violent metaphor. But get used to it. But hey, how about that as a flip on its head version of my saying, better get used to it. They're violent. But by the way, get all the violence out of your system with the story problems, then you treat real people with kindness, compassion, yada, yada, yada. It works for me. So these don't cancel. They are fighting each other, one positive, one negative, but it's not a fair fight. The top one is stronger. Technically, the number here is a 1. This is a -1. What would that number have to be on the bottom in order to be a fair fight? Go ahead, Megan, finish now. What should this be in order to match perfectly? -2y, yeah. I want this thing, I want to be -2y, because it'll match the positive 2y perfectly. Can I get it there? Well, there's a rule in algebra that says you can do anything you want as long as you do it to both sides. That includes multiply. I would like you to multiply by what? Nick? 2. If you multiply this by 2, does everybody say it's going to be -2y? But you have to do it to both sides. So the top one, I'd just like you to rewrite. We're not doing anything to that. 5x plus 2y equals 54. And then the bottom one is what? Go ahead and take that one.
So it'd be
6x plus -2y equals what? 56. Good. How did I write 5x? 54. My brain scares me sometimes. Is everybody right? Sorry, at home that was not 5x, it was 54. I spazzed. So, does anything happen now? All right, Claire, take over. Right. We're going to add these together and the y's cancel. What do you have left? 11x. 110. Go for it. Divide by 11. Does it go any of that? X equals what? X is what, I'm sorry? 10, yeah. By the way, happy Hanukkah early. And then what do you do with the x equals 10? Shaylee, take over.
plug it into one of the equations.
Yeah, you notice there are 4 equations you can use. There's like the top left, top, bottom left, top right, bottom right. Any of them will work. I would suggest something that's small, but to knock yourself out. Which one do you like?
3x plus -y plus
Okay, it's nice and small. What does it look like if you do?
So 3 times 10.
3 times 10?
Plus -y
Uh-huh.
equals 28.
Equals 28. Go ahead and solve. What is 3 times 10?
30.
30. Now what?
Then you subtract this one.
Subtract 30 from both sides, all right. What do you get?
-y equals -2.
How do you get y by itself?
Divide by -1.
Yes. That's one of the reasons why I put the 1 in front of the y, because you can actually see what we're dividing. We're dividing by -1. What's the final solution?
Y equals 2.
Positive 2. Done. Does that make sense? Elimination can still work, but sometimes we have to give one of the two equations a boost. We have to make it twice as strong, or 3 times as strong, or something like that, in order for it to actually work. Now, let's get totally fun. I mean fun in a slightly sarcastic sense. With something that's exotic, something dramatic. Something, I don't know if I'd call it exciting, but it's exciting in the same sort of way as having a rabid wolf burst out of the woods and lunge for your throat. It's exciting. It's not exactly something that you'd want. So it's kind of like that. That was a really stretched metaphor. We'll try that. 7x plus 6y equals 27. And then negative 2x plus 3y equals, hang on a second, negative 3. Solve. Now you have a little bit of a choice here. The equations are ready to add, but which variable do you think is trying to cancel?
Yeah.
Probably the loss.
The y is possible. There are two possible answers to this. Why do you think the y's would be a good candidate?
Well, because you usually multiply by two. By
Yeah.
negative two.
It'd be easy to get them up to the same strength. You just make the bottom twice as strong. What's another possible argument? Yeah.
The
Right.
negative 3x will be better.
Yeah, there's another argument for these. Why?
Because it's negative 2x and it's positive.
One is positive and negative. These are already fighting, so they don't quite match up. These, the problem is this would be great to match up, but they're not fighting. Glory be to God. Hi. Okay. Does that mean I have to turn my selfie stick off now? Is Will coming or no?
Let's go.
Anyway, so we've got. Okay. Well, I can turn this off. We've got like, I'll put it up on YouTube. It's like the first. It's the first 10 minutes of the. You know why not? I'll just record this. I went to all the trouble. So, memory is cheap anyway. So do you see here? The x's, there's a temptation to use the x's because one's positive, one's negative. Those are already fighting. These are not fighting. They're sort of, I'm not interested in fighting so-and-so, he's my buddy. We're both positive. We're both on the same team. Now, by the way, this is where do not use this in the moral life. This metaphor is a metaphor. I want to get these two to fight. So how do you do that? That means I basically have to kick one of them and make it negative. Don't do this in real life, I beg of you. But I agree that the y's are good, but the bottom, what should the bottom be in order to make this thing work? Josh?
It should be negative 6.
Negative 6y. Howdy. I want this to be plus or minus 6y. Does that make sense? I want this to be negative 6y. Is there a way to do that legally? Go. Multiply by negative 2. Not only are you making it bigger and stronger, you give it a good swift kick and make it mad, and the two of them are not fighting each other. Again, metaphor, not real. Please don't do that in real life. And don't spread rumors. But you guys wants us all to fight in a death cage match. Oh, no, come on. 7x plus 6y equals 27. And then can somebody give me the bottom? Let me see. Sam, take over.
Probably 4x
Positive 4x,
plus negative 6y
negative 6y equals
equals 6.
positive 6. Does that make sense? Now, I think this thing is ready to roll. So, Blaze, take over. Did your dad together? And get what?
11.
You'll have it. There you go. Good save. And then what happens here?
They cancel.
Cancel. And then what?
It's 30, 30, and 33.
33. Good. One more step.
Divide by 11.
Uh-huh. What do you get?
X equals 3.
X equals 3. Okay. Take over. Rainy. What do you do with that?
Plug it in.
Plug it in where? Pick your favorite. Bottom one? Sure. What does it look like if you do?
Negative 2, C, 3.
3. Okay.
Plus 3y equals negative 6.
Yeah. Go ahead and do it for me. What's negative 2 times 3?
Negative 6.
Negative 6. Now what? Yes, so add 6 to both sides to get rid of that, because that's farthest away from the y. Okay, so what do you have left?
For y equals,
3. Merry Christmas.
divided by 3,
Divided by 3,
y is 1.
y is equal to 1. Done. Does that make sense? Could you have used the x's? Is it possible that you could have used the x's to solve this problem? You notice they don't match up very well. 2 and 7, you can't just boost one of them and get them happy. Well, the answer is yes, you can. And I'm going to show you. 7x plus 6y, gentlemen, equals 27. And then negative 2x plus 3y equals negative 3. Let's assume I want to attack the x's. I want the x's to cancel. I want them both equal, and I want one positive, one negative. Can anybody think of a number big enough to handle both of those? Yeah.
14.
14. If I can get them both up to plus or minus 14x, both of them will be equal strength, and then one positive, one negative, they'll fight, wipe each other out, etc. Abby, take over. I want the top one to be, and I don't care which one is positive, one is negative. The top's positive anyway, so. Can you get this up to 14? What would you multiply by?
2.
2. Do the entire row.
So 14x
Uh-huh.
plus, 12.
Exactly.
Sorry, I was
12y.
thinking you had to get the 6.
No, you're fine. And then 27 times 2 is, I do 20 times 2 and then 7 times 2.
Wait, sorry, what?
Oh, what's 20 times 2?
40.
40. And then 7 times 2?
14.
Put them together.
54.
54, yeah. Okay, take over. Katie, what do you multiply the bottom by?
Negative 7.
Negative 7, that's clever. However, that would actually make it friendly and not fighting this anymore.
So that's 7.
Exactly. Multiply it by a regular 7. Because I want one positive, one negative, otherwise they won't cancel. Go ahead and do it.
Negative 2 times 7 is
Negative 14 x, okay.
And,
This is a plus, sorry. I ran it over. Plus 21y equals, good. Does that make sense over so far? Somebody run this for me. Will, go for it. What happens with 14x plus negative 14x?
So it cancels. So
Cancels.
it's negative 9y. Not, wait.
Oh, these are both positive.
Oh, so it's negative, or no, so it's positive 33y.
Yeah, 33y equals
33.
33. Merry Christmas again. Go for it.
Then you just divide it by.
Go by 33 and get what?
Y equals 1.
Good. Please, for the love of all that's holy, do not put y equals 0 in the middle of a test. That's embarrassing. So, are we done? Now, Taylor, take over.
I need to plug it into the equations.
Yeah, we've got y. Use it to get x. Pick your favorite equation.
So negative 2x b.
Okay.
Negative 2x plus 3 times 1.
Times 1 equals
Negative 3.
negative 3. So that's really negative 2x plus
3.
3 equals negative 3. Go for it.
Add 3 to both sides.
Actually,
Or subtract.
subtract 3 to both sides. What do you have so far?
Negative 2x equals negative 6.
Good. One more step.
5 by negative 6.
Okay. Solution?
X equals 1. Or 3, sorry.
3. Good save. Done. And if you notice, exact same solutions. You can attack the x's or the y's. There'll be, one might be easier than the other, depending. Does that kind of make sense so far? Alrighty. Quick question. Has anybody done 4A yet? Has anybody started 4A yet? Good. Scratch it off. It's an interesting problem, but we don't need it. And I want to move on to more exciting ones. So, advance on to, I believe it is page 117. I think I'm actually going to delete a few of these as well. They were really, well, hang on. I have 5 through 25 multiples of 5. Oh, wow. Ew. Yeah, I'll keep that. 5 through 25 multiples of 5. 31. I'm going to have to give you a little bit of a boost on number 31. But just to let you know, I want you to do 5, 10, 15, 20, and 25 as the beginning of the assignment. This is on page 117. To solve the system, and they leave you up to whatever method you want to use. You could use graphing, I would not suggest it. You could use substitution, which is easy if you get a variable by itself. Like, look at number 1. You're not doing number 1 anyway, but that's relatively easy to get x by itself or y by itself. So number 1 would be relatively easy to do substitution. Number 10, you see everything has a number in front of it. All of them have coefficients that aren't 1. I would not recommend doing substitution on that one because it's a beast. Trying to get x by itself, you're going to have fractions everywhere. So you can also use elimination, which is usually the method of choice. When would I use substitution? Usually if there's a letter already by itself. That's just too tempting. I just go, all right, fine, I'll do substitution. Otherwise, I use elimination. Do not be ashamed to do that. The graphing, I would not do in this assignment at all, my humble opinion. I will warn you, number 25 is going to take a little while. Feel free, this is one of the few ones I would say, feel free to try out a calculator on number 25. Because the answers are going to be big and they're going to be fractions. They actually give you a piece of advice. You know how we solve for y's here and then we solve for x's there? Normally you just solve for one and then plug in to get the other. Could we have solved for x and then started over and solved for y? Yeah, they're actually recommending you do that in number 25. Because the fraction you get is going to be so gross that plugging it in is going to be a nightmare. It's not, well, not a nightmare, that's a little too harsh. Decidedly unpleasant. It won't make you forget Christmas. It's painful. I'll leave it here on your own. But just be prepared, number 25 has some kind of gross fractions. IT, where to go from there? Yes. I need to show you what I affectionately call suspense as I wipe the board. Weird solutions. What do I mean? For example, suppose I give you 3x plus 8y is equal to 7. And then negative 9x plus negative 24y equals 10. I would like someone to solve that by elimination, please. Who's feeling brave? Or foolhardy? Or reckless? Go!
We could start off almost on the top and maybe there.
Okay, so are you attacking the x's or the y's?
Yeah.
The x's? Okay. So has everybody noticed that they're already fighting, but the top is too weak? It needs to be boosted? By how much?
No.
By 3. Yeah, if you do negative 3, you're going to remove its fighting spirit, so to speak. So, let's go for it.
It would be 9x
Uh-huh. Uh-huh.
equals 20.
All right. And then the bottom you just leave because it's the right side already. negative 9x plus negative 24y equals 10. Go ahead and solve this while you're at it. What happens here?
And just get X.
Not x, but it's 0x, which is the same as 0. It cancels completely. Yeah, by the way, this is a good point. 9x minus 9x is not x. It's 0x, which is just plain old 0. It'll just cancel completely. Very good point. How about this?
And 0.
Now, isn't that interesting? Equals what?
31.
What do I put here? What's left? I can't just leave it blank. Yeah,
0.
0. This is awkward. This, at what level of awkward? It's like this. Your mother says, there's a very important cake I need you to pick up at the bakery. It's for Great Aunt Helga's 90th birthday. Okay. And it's this big, huge, fancy $150 cake. And then on the way home, you put it safely in the back, and then you drive and drive and drive. And then for whatever reason, you pick up a hitchhiker. And by the way, don't do that. And then you drop the hitchhiker off, and then you get to home, and you look in the back seat. Okay. Oops. Hitchhiker took the cake, by the way. Another reason not to pick up hitchhikers, they steal your cake. That was a good metaphor anyway. I was trying to get x by itself. The x is gone. So it's kind of like the powers that be of math come up to me and say, so, Mr. Conklin, so what's x equal to? I don't know how to tell you this, but I lost your x. All right, well, tell me what y equals. I really don't know how to tell you this, but I lost your y too. Are you a complete incompetent or what? No, it's not our fault. But does everybody agree that this is a strange, or what I would call a weird solution? There are no x's. I'm looking for x equals 10 or y equals 3. I got nothing. Bupkis. So what do I do with this? Well, question. So I walked up to, I'll change the metaphor a little bit. I walk up to this person who's solving this and I say, so, what's the value of x? And he said, I gotta tell you, 0 equals 31. Okay, now I have two problems with this. Number one, you didn't answer my question. And number two, 0 is not equal to 31. Weirdo. So, what? Is this true? 0 equal to 31? No, it's not true. Question, how often is it true? Never. Please write this down. Never true. Let me review from yesterday something. These two equations from last chapter have graphs. I mean, the graphs are horrible, but does everybody at least agree that they're standard form? You could graph them if you really had to. They're graphs. I don't know where the graphs are, but this is like, oh boy. 27/7 is the x-intercept. That's horrible. That's almost 4. And then the 6, oh my word, it's like 5. And then this would be like 1.5. And this is like -1. So it's something like this. Do those two lines cross anywhere? Yes. Tell me where. You should be able to tell me. 3, 1. These two lines cross at 3, 1. We would never be able to get that by graphing. But the solutions are the same as the intersection. So in other words, let me put it this way. Whenever x equals 3, y equals 1 is true, the lines cross. Write that down. Whenever x is 3 and y is 1, the lines cross, and that only happens once at 3, 1. because x is 3 and y is 1. You notice they only cross once, and there's only once that ever happens. Does that kind of make sense? So whenever the answer is true, these cross. And it's only true once. Look over here. Is this true? No. How often is it true? Never. How often do these two lines cross? Never. Tell me, oh geometry remembering people, what is that called? Parallel. You have just found parallel lines. That is your solution. A solution is where they cross, and there is no crossing. So you just say they are parallel. There is no solution. Ever. Does that make sense? If you get a weird answer that's never ever true, you've just run into two parallel lines. I guarantee. Now, is that the only weird solution on Earth? No. Try this. And I'm going to give you a substitution problem just for old time's sake. Another example. Y equals 2x plus 1. And then negative 4x plus 2y equals 2. I have one in slope-intercept form, one in standard form. I would like you to solve this system of equations. And I would recommend you use substitution. You see why? Because y is already by itself. It's pretty easy to plug it in. Try it, somebody. Back up. Take, whoops, I'm putting the data dot on the wrong. Ew, okay. Got a blue finger now, that's okay. Rewrite this, but plug in for y.
Negative 4x plus 2
Parentheses.
2x plus 1
Okay.
equals 2.
Equals 2. Go ahead and simplify this for me.
So it'd be negative 4x plus 4x
Uh-huh.
plus 2 equals 2.
Does anything simplify?
Negative 4x and 4x cancel.
Cancel. What's left?
2 equals
Weird solution. Not the same sort of weird solution before. There are different types of weird in the world, trust me. I have personal experience. 2 equals 2. Now, I hope I don't have to convince anybody that that's strange. So what's the value of x? I got a secret for you. 2 equals 2. I know. Can you tell me x? 2 equals 2. You're not going to tell me x, are you? Is this true? Yes. How often is it true? It's always true. Write that down. Always true. And when we learned about graphing, we learned that whenever that answer is true, the lines cross. Whenever this answer is true, the lines cross. How often is it true? Always. So guess how often the lines cross? Always. What's that called? It's called coinciding. These lines are coinciding. Okay? Those will be showing up in the homework. I will caution you. I actually have 3 more words, actually 4 more words. They're relatively easy. And they have a stupid story that goes with them. They're about what kind of lines. I'll just tell you. It's shorter to tell you than to try and explain it. Please write these down. That's probably the last thing I'm going to have you write. Dependent versus independent. Then consistent versus inconsistent. What do these mean? Well, this is talking about any pair of lines. Any pair of lines will either be dependent or independent, and they'll be either consistent or inconsistent. So it's one of each. What does it mean that a pair of lines is dependent? Well, in real life, how do you tell if something is completely and utterly dependent on you? Think of like a younger brother or sister that's absolutely 100% totally dependent on you. Needs help going to the bathroom. Needs help getting food. Needs help going to bed. Needs help with anything. How do you tell something that's absolutely 100% totally dependent on you? First of all, no other human being is 100% totally dependent on you. They're dependent on oxygen and things other than you. But how do you tell if they're dependent? They never leave. Two things that are dependent will always be together. They will never separate, ever. Ever. Yeah. What is it? Independent. Independent, that means they have quote-unquote lives of their own. Oops. Now what does that mean? Does that mean that you never see each other? Well, no, you can visit each other for coffee, but you don't stick together 24 hours a day, 7 days a week. Let's translate this into graphs. Can you think of two lines that never ever leave each other? What's that called? Yeah, coinciding. Two lines that never leave. Here's the graph. By the way, if you want to run a graph of coinciding, it looks like this. That's the symbol for coinciding. They're coinciding. So whenever they say that something is dependent, you immediately see coinciding. Independent, they have lives of their own. That doesn't mean they can't meet, but it means they're not stuck together. There are two options for this. They could be parallel. They definitely have lives of their own. Or they could just be plain old regular intersecting. Here, I never want to see you, I don't want to see you either. Parallel. Here they say, hey, let's meet up for coffee. Great. So they meet up once, then they go their separate ways. So either parallel or regular intersecting. In other words, they can go wherever they want. They can meet up, they cannot meet up, it's up to them. That's independent. Does that kind of make sense? Consistent, what does that mean? Well, think of, apparently I am very consistent because otherwise people wouldn't have this quote board on me. I keep saying the same sort of things over and over and over. So I'm fairly consistent. At the beginning of every hour, I'll say, okay, please stand, or something like that. It's relatively predictable. I say the same thing again and again and again. That's called being consistent. Consistent means same. I would say at the same place. In line language, it means they intersect. There are two possibilities for that. Can you give me two different types of line pairs that intersect? Give me one. The four categories are parallel. Well, don't worry about perpendicular. They don't care if it's 90 degrees for these. Parallel, regular intersecting, coinciding. I use three. Which of those two allow an intersection? Yeah.
Regular intersecting and coinciding.
Yeah, regular intersecting intersects, and coinciding definitely intersects. They intersect all the time. That make sense? So two lines are consistent if they touch, if they're in the same place somewhere. What does inconsistent mean? If consistent means they intersect, what does inconsistent mean? Go. They never touch. There's only one that categorizes that. What is that? Yeah. Parallel is the only possible categorization. So now, parallel lines How would I categorize parallel lines? First of all, parallel lines, dependent or independent? Anybody? Yeah, good. They're independent. Consistent or inconsistent? Megan. They're inconsistent. That means they don't touch. That would be your answer for, what am I doing? Inconsistent. That would be your answer for one of the problems in 31 through 38. Coinciding, can somebody describe that for me? The two numbers, like two words. One word from the top and one word from the bottom. Josh, help me out. Is it independent or dependent for coinciding?
Dependent.
Dependent. And consistent or inconsistent?
Consistent.
Consistent. By the way, there's a potential extra credit question on the test. There is one word from the top that just does not ever match with the word on the bottom. Anybody know which one? There's one matchup, one from here and one from here, that will never take place in real life. Let me see it. Right. Dependent and what?
Inconsistent.
Dependent and inconsistent. That basically means they never leave each other and they never touch each other. How do you work that? You can't. This says they never intersect, and this says they always intersect. That's impossible. That's a contradiction. So yeah, there's one matchup that does not work, and you will never have that as an answer in your book. Regular intersecting. Regular intersecting, can somebody categorize that for me? Austin, help me out here. Consistent or inconsistent?
Consistent.
Consistent. That means they touch. Oh, I did it backwards. And then dependent or independent?
Dependent.
Do they have lives of their own, or are they always stuck to each other?
Well, I guess they're independent.
They're independent. They can meet up, but they're not stuck to each other forever like a dependent line would be. They're not coinciding. Make sense? Now, take a look, please, on page 118. For example, problem number 31. They did not give you graphs. They gave you two equations. Any idea how to tell whether they're consistent, inconsistent, dependent, independent? Guess what you'll have to find? Guess what piece of data is particularly important for all of these problems? It's very similar to last chapter when you had to determine if they were parallel or not. You have to find the what?
We did slope.
Slope. You gotta find the slope of both of them, then you gotta find the y-intercept of both of them. If you find out if they're coinciding or parallel or regular intersecting, they don't care about perpendicular in this particular section. But if you can find out if they have the same slope, same y-intercept, you're dealing with this. If you find same slope, different y-intercept, this. If they have different slopes, then they're just intersecting. Make sense? That should be all you need. So, I think you're good to go. Let me just look ahead here. Substitution, okay. Yeah, 45 and 47, they insist you do substitution, but it shouldn't be that hard. So go for it. Yeah, we got 6 minutes to pound away at those. Ask me if you need any help. Okay.
I wasn't here on Friday and I never looked at these.
Oh, yeah, good point. Anybody else need the homework guide sheets? Who didn't get it? The chapters 4 and 5. Yes, so 5, 10, 15, 20, 25. Yeah, and skip everything. Yeah, and please do not do 5, 6, 7, 8, 9, 10 all through 25 and then do all of them 5 times in a row. I had somebody do that once. That was unpleasant for all involved. And I think I can turn this thing off now.